has to be constant. So what does our tangential acceleration have to be if we want the tangential velocity to be zero? I mean, constant, zero. Sorry. Okay. Now, what is the centripetal acceleration? V squared over r? And V in terms of the rotational motion is what? R omega, and don't forget to square the whole thing. So even though it's not speeding up around the circle, it's always accelerating towards the center like any other circular motion. So it'll be r omega squared. And what does r represent? The amplitude. So then take this and dump it back in here, a omega squared. So you calculus people, is that what you expected it to be? Yes. Yay. So I did non-calculus to show it. All right, so let's look at some maximum values. This should be pretty easy. So I'm just going to write down our equations for motion. Again, V of t is equal to a omega sine omega t. And then a of t, the acceleration, is a omega squared cosine omega t. All right, so let's talk about max values. What is the maximum that cosine of omega t could ever be? Cosine of an angle goes between what and what? So what's the biggest it could ever be? 1. Okay? The cosine of an angle, the biggest value you can get is 1. Correct? Incorrect? Okay. So then that means that x of t, or x max, well, if cosine, the biggest it can be, is 1, then it would be equal to the amplitude. And that should make sense if you look at the graph. The maximum x displacement should be the amplitude. I put the absolute value sign in there because sometimes we want the positive one and sometimes we want the negative one. So just the maximum distance, if you want to call it that, is the absolute value of your amplitude. All right, what about velocity? What's the maximum value that sine of any angle can be? 1. So then what is my maximum velocity? A omega. Because sine of what? Pi? Is that 1? Pi over 2? Uh-huh. And all I care about is if this whole thing is 1, then that will give me a maximum because it's between 0 and 1. And then what about my acceleration? Yep. So the max would be a omega squared. So those are really popular and helpful when you're solving problems to know how to find the maxes. All right, now let's look at our omega. Now, what does that mean? Omega is angular speed, which is theta over t. If you go around one time, what's theta? 2 pi radians. Very good. And what do you call the time to do that 2 pi? The period, right. So, omega, the angular speed, is equal to 2 pi over period. Okay, so omega stands for the angular speed, or sometimes, and more often when we're talking about oscillations, we'll use the phrase angular frequency. Okay, and this t stands for the period, and it's measured in seconds. So what is the frequency measured in then? Angular frequency. Radians per second, but radian really isn't a unit. So it could be 1 over seconds, which also could be seconds to the negative 1. But I will tell you that you'll most often see radians per second in this unit because we're also going to discuss frequency, meaning like linear frequency compared to angular frequency. Okay, so speaking of frequency, F for frequency. What is frequency? How frequent do you do something? What would you do if you were going to figure out how frequently you can make a lap around the gym? How frequently, not your speed, but how frequently can you go around the gym? So, was it the cycle over the time it takes to do those cycles? Okay, so what if we go around one cycle? What's the time for that one cycle called? The period, thank you. So that means that frequency is 1 over period. And you came up with that, with me just poking and prodding you in the right places. What? Okay, so this is frequency. Such as the frequency that you tune into on a radio. Okay, those are megahertz and things like that. And this is still period. But angular frequency and frequency are not the same. So frequency would be still, because period is seconds, it would still be 1 over seconds, which could still be seconds to the -1. But we usually call that hertz. All right, so now let's look at an example of a position function. So what if we have a position function that looks like x of t is 5 cosine of pi over 3 times t. So just by looking at that equation, we should be able to define a few things. What's the amplitude? It's 5. The maximum distance is 5 meters. I put my unit out here at the end. All right, what about the angular frequency? Would that be pi over 3? Radians per second? What about the period? How could we find the period? Omega equals 2 pi over period, so period equals 2 pi over omega. Very good. So I have 2 pi over 3. That's 6. And period is measured in what? Seconds. Very good. What about frequency? Like good old hertz frequency. 1 over 6 hertz.